Assalamualaikum. My name is Haziemah Binti Roslan. My metric number is 2020980557. Today, my friends and I are going to present Laboratory 9 experiment, which is film boiling condensation. Demonstration of film-wise and drop-wise condensation can be investigated by carrying out film boiling condensation experiment. Vapor can condense in two different ways of a cool surface that are film-wise and drop-wise. Drop-wise condensation is more effective than film-wise condensation with the same temperature. Difference between the vapor and the surface. The special water-cooled condensator surface finish enhance the process of drop-wise condensation by preventing wetness of the surface. In steam vapor, the presence of air slows heat transmission substantially. This experiment can be used to any sector looking to improve heat transfer efficiency. At constant pressure, we were going to determine the film and drop-wise heat flux as well as the surface heat transfer coefficient. When a vapor changes from a gas to a liquid with a large heat transfer coefficient, it is called condensation. Film-wise condensation occurs on a vertical or horizontal plane when a film of condensate forms on a surface and flows by gravity. When small drops develop on a surface, drop-wise condensation happens. We can calculate the heat transfer coefficients by using Nurul equations. Nurul has made assumptions when the vapor through the films and to the wall undergo conduction, heat transfer will occur. In this experiment, we are able to obtain data for temperature of water and time taken for condensation to happen.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Hanis Binti Muhammad Zamri and my student ID is 2020 98 58 97. Condensation is the transformation of water vapor in the air into a liquid water. In other words, the water vapor in the air from your hot shower cool when it comes in a hot contact with the cool nearest surface. This leads to water vapor to condense or change from a gas to a liquid. Moisture, droplets of water and a fog have accumulated in the mirror which you observe. Condensation occurs when a saturated vapor, pure or multi-component, comes into contact with an object such as wall or other contaminant that has a temperature below the saturation temperature. Condensation can be categorized into two parts, which are film-wise condensations and also drop-wise condensation. For film-wise condensation, the condensate wets the surface and creates a liquid film on it that slides down under gravity's effect. Low heat transfer rates will come from film condensation because the condensate film obstruct the heat transport, and the thickness of the resulting film is determined by several factors such as surface orientation, viscosity and also condensation rate among others. For drop-wise condensation, it occurs when a vapor condenses on a surface non-wetted by condensate. For non-metal vapors, drop-wise condensation gives much higher heat transfer coefficients than those that found within the film condensation. So, the best surface is constantly exposed to vapor during drop-wise condensation due to coalescences between drops and sweeping action by the falling drops as they are removed from the surface by the gravity or vapor shear stress. There are three objectives for this experiment. First one is to demonstrate the film-wise and drop-wise condensation. The second one is to investigate the effect of different surface materials on the rate of condensation. And the last objective is to relate the process of condensation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Liyana Binti Zahar from Group EH220 and I will present for the part Theory and Procedure. In the film-wise condensations, the surface over which steam condenses is wettable. Once the steam is condensing, the film of the condensate will form at the surface. The film-wise condensations will affect in a very low heat transfer rate as the film condensate that obstruct the heat transfer. The thickness of the film form relies on the parameters together with the orientations of the surface, viscosity rate of the condensations, and others. While in the dropwise condensations, it takes place while the surface over which condensations that take place is not wettable. The droplets are formed when the steam is condensed. The drops that emerge will become bigger, fall under the gravity formed in the dropwise condensations. High heat transfer rate are achieved, and the chemicals that has been used is to ensure that condensations take place the dropwise. Based on the condensate design, the experimental result obtained depends on the nature of the rig design and also the weakness of the heat flux on the surface. The heat exchanger design can be performed commonly via LMTD. The LMTD equations are as the given below. The apparatus that we need for the experiment is plastic container with a lid in medium and small size, hot water and cold water, stopwatch to record the time, and the cooking oil.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zaiful, Alif, Izham, Zainurin. My metric number is 2020970627. I will continue on procedure, result, discussion and conclusion. We will start with dropwise condensation. First, prepare a container with the lid. Then, apply a thin layer of cooking oil. Next, pour in hot water. Then close the lid tightly. From here, you can start to observe and take the time taken for it to fully condense. Then let it be for 50 minutes for further observation. Then we can open up the lid and see the result. Now repeat back with cool water. Prepare a container with the lid. Apply a thin layer of cooking oil. Pour in cool water. Close the lid tightly and start to observe and take the time taken for it to fully condense. Let it be for 50 minutes for further observation. After 50 minutes, we can open up the lid back and see the result. Then we move with foam-wise condensation. First, prepare a container with the lid. Then pour in hot water. Close the lid tightly. Start to observe and take the time taken for it to fully condense. Then let it be for 50 minutes for further observation. After 50 minutes, we can open up and see the result. Now, repeat back with cool water. Prepare a container with the lid as usual. Pour in cool water. Close the lid tightly. Observe and take the time taken for it to fully condense. Then let it be for 50 minutes for further observation. After 50 minutes, we can open up the lid back and see the result. For the result for dropwise condensation with using hot water, it takes about 145 minutes to fully condense, and the observation has shown. Meanwhile, for the cold water, The time taken for the condensation to happen, it takes about 40 minutes. And the observation also has shown. The result for the foam bus condensation with using hot water, it takes about 0.5 minutes, and the observation has shown. Meanwhile, for the cold water, it takes about 20 minutes for it to fully condense, and the observation also has shown. Discussion. We managed to carry out the objective accordingly. Firstly, we had managed to demonstrate the condensation of firm-wise and drop-wise. Next, the effect of different surface material on the rate of condensation also come into observation, which in the experiment is carried out by two different surfaces, which is hydrophobic surface and hydrophilic surface. The hydrophobic surface is demonstrated by applying a thin layer of cooking oil in the surface of the lid. Meanwhile, for the hydrophilic surface, just using a bare lid. These two different hydrophobic and hydrophilic surface area reacted or show different type of condensation as it achieved our third objective, which involving the thermodynamic theory. We also investigate the temperature difference in the condensation process on the rates of condensation. So cold water and hot water were used in order to carry out the objective. Varying type of surface show different condensation, firm-wise and drop-wise, that will form on the surface. To be detailed, it is affected by the wettability of the surface. The wettability here means it is either the surface is hydrophilic, hydrophobic, or super hydrophobic surface. If the surface is hydrophilic, then it will form a firm-wise condensation. Meanwhile, if it's hydrophobic, then it will form a drop-wise condensation. For the experiment, it is carried out in room temperature condition. Some error might happen like different air humidity since all the setup just carried out at open area. The method that we use is by using two same container, with one of the container is being applied a thin layer of cooking oil on the lid to demonstrate the hydrophobic surface. From the theory, we knew that hydrophilic surface will create a firm-wise condensation and the hydrophobic surface will create a drop-wise condensation. This is because hydrophobic surface, due to the low surface energy of the hydrophobic layer, condensate form in droplets, which will subsequently absorb in the porous structure. The suction of condensic droplets on the hydrophobic layer result in thin firm condensation with superior heat transfer performance compared to conventional firm-wise condensation. Therefore, we try to carry out the experiment efficiently by run two different surface leads using same temperature of water at the same time. Firstly, both different container with one of them already being applied a thin layer of cooking oil is poured with hot water. Time taken is recorded immediately. Not long after we pour the hot water, we can see some different observation on the lid. For the bare lid, it takes about 30 seconds to start fully condense and as expected, it forms a firm-wise condensation pattern. At the same time, the lid with a thin layer of cooking oil takes about 1.5 minutes to condense and a drop-wise condensation pattern is clearly visible. Bear in mind that some condensation may not be fully accurate while being captured by the camera, as few delay seconds might be needed to open up the lid and to take the picture. As the lid being opened, it is exposed to open environment and might experience some sudden temperature. They may cause the pattern not fully accurate. Next, the same setup are repeated with cool water. This is to investigate the temperature difference in the condensation process on the rate of condensations. Both different container with one of them already being applied a thin layer of cooking oil is poured with cool water. This process takes longer to show some result compared to how cool water have much smaller temperature difference compared to surrounding temperature. However, after 20 minutes, we can see the lid with hydrophilic characteristic, which is the bare lid become fully condensed and show firm-wise condensation pattern. Just a thin layer of water that barely captured by the eyes of the camera. Then, after 40 minutes, the lid with thin layer of cooking oil shows same result. A few tiny water droplets visible on the surface of the lid. As mentioned earlier, some accuracy may happen during the photoshoot session. Now, we can see the different factors affecting the form-wise and drop-wise condensation, plus with how temperature difference playing a role in controlling the rate of condensation. Overall, the appearance of form-wise condensation is happen because the wettability of the surface is hydrophilic. Hydrophilic causing the vapor that condense to have tendency to stay away to each other and causing a thin layer look alike, while the drop-wise condensation is happen because the wettability of that surface is hydrophobic. It makes the water particle to stick together and form a droplet due to the surface tension as explained before. Another factor that managed to carry out is the temperature difference is determine the rate of condensation. Hot water is more likely to condense faster as the temperature difference is much higher compared to the surrounding temperature. Meanwhile, different story with cold water. Due to much smaller temperature difference, it takes longer to condense. Lastly, all the result from the experiment is considered acceptable as it follows the theory. Conclusion. In conclusion, the lid with thin layer of cooking oil produce a drop-wise condensation and take about 1.5 minutes to condense with hot water and 40 minutes to condense with cool water. Meanwhile, the bare lid produce a foam-wise condensation and take about 0.5 minutes to condense with hot water and 20 minutes to condense with cool water.
As mentioned earlier, this experiment is carried out at home, not appropriate location a scientific experiment. However, a few adjustments can be made to keep the accuracy of result increased. For example, we can try to carry out the experiment in a much tight environment like in a room where there is no viscous air movement in order to keep the condensed water is not affected, especially the thin layer condensation, as it is easily to evaporate back into the air during the photoshoot session. Next, since we have limited apparatus, we need to make sure all the apparatus is fully dry before carrying with the next experiment in order to eliminate any inaccuracy in the data.